Good afternoon, folks. How's everyone doing today? Having a wonderful Unite? Yes! There we go. Can always count on the 2D crowd. Now, how many of you are 2D game developers? Can I get a show of hands? Wonderful. How many of you are going to be 2D game developers? You're thinking about it. I can see. And some shy hands as well. OK, wonderful. All right, so today I'm going to talk to you about new 2D workflows and AI enhancements for sprites. I'm Rus Scammell. I'm the product manager for all things 2D at Unity. OK, this is the 2D team. These are the folks, the wonderful folks in Singapore and also in the English countryside that I have the honor of working with every day. Now, we're a team of developers, as well as quality engineers, designers, product management, and technical writers. And our mission, as always, is to make Unity the best game engine for 2D games. I also want to shout out to the tech content team. A lot of the amazing stuff that you see in this presentation is the work of the tech content marketing team. They are pivotal in the creation of all the ebooks that you must have seen that were showcased so many times, and all the samples that share so much useful production information and wisdom for experts by experts. Now, today we have a lot to share. We'll be looking at some creative workflows, diving into pixel art, exploring performance features, decrypting physics workflows, and unpacking some advanced customization capabilities. And at the end, I'll show you a little sneak peek on some progress, some in-progress work that we're doing in 2D graphics. All right, let's go. First up, creative workflows. So I want to talk a little bit about the evolution of the creation of art in 2D games in Unity. So when we began, we added 2D foundations, world building, and physics. And Unity was at the heart of your 2D game development experience, right? You would import your art from DCC tools and then set them up and integrate them in Unity to make your games. Next, we added bone-based 2D animation and real-time 2D lights so that lighting and animation became more dynamic. And lights can change at runtime, as well as animation clips that could be played at different speeds and blended easily. This meant that art authoring was happening more and more in Unity and can be previewed directly in games. Now, in Unity 6, we have started infusing AI into the 2D toolset with sprite enhancers. These let you stay in the creative flow state and make it straightforward to adapt existing art to better fit your project. In Unity 6, the value comes in two basic areas, right? We're adding more control for gameplay and graphics, and we're helping you save time through the automation of menial tasks. As I said earlier, alongside all the improvements to the core product, our teams have collaborated on producing a fire hose of content and samples. Professional technical content like this that helps you make the most of Unity. You can find all of the videos related to this on Unity's official YouTube, and the ebooks are on the website. Now, at the end of the presentation, I'll share a QR code so that you can get to all of those ebooks. It's a link to somewhere on the website. OK, let's zoom in on an AI-powered feature, Muse 2D enhancers. So when we're prototyping a project, it's a real accelerator to be able to adapt existing sprites. We have the upscaler, which is aptly named because it helps you to scale up older, lower-res art to a high-res modern game. Recolor takes a reference image and extracts a palette. Then you can use that to recolor images to better fit your theme. And remove background makes it easy to extract the subject from an image, making an immediately useful sprite for your game. OK, let's see these in action. Now, sprites often need some adjustment and enhancements. They're not often ready to go before they can be used in game projects. let's look at some of these sprite enhancers that I was talking about that are currently in pre-release. So I want to upscale. I want to use an older, lower-res sprite of a bronze helmet in a higher-res game. What we can see is a little too small. So I'm going to use the Muse 2D enhancer in the sprite editor window. I'm going to use the upscaler enhancer, and this is going to effectively double the resolution of this to 512 by 512 pixels. Now, we'll be able to see that it preserves the details of the older art and makes it look good at a higher resolution in a more modern game. Next, I want to add the same helmet to a swamp level, and I want it to match the existing color scheme. So I'm solving this problem by using the recolor enhancer. So to do this, I'm going to drag a background image into the reference panel, and then the enhancer extracts the color palette, as we said earlier, from this image based on the most prominent colors. Then uses this palette to change the colors of the red helmet to a more matching green scheme. As we can see here, once I hit apply, it fits a lot better into that scene. OK, in this one, I'm making a hidden object game. And I've got a library of art, and I want to add some props from it. Now, I want to use this helmet. But as we can see, it's got an annoying gradient background on it. It doesn't fit. It doesn't work. So I'm just going to use the remove background enhancement in the sprite enhancers, in the sprite editor window. I hit a simple click, spin for a little, and I'm done. And as you can see, that fits perfectly in the level. Super. OK, so why is it important to be able to enhance sprites? Let's take a look at some numbers. 30% of all the Unity projects that we see out there, they're based on a 2D template. That's huge. And if we look at a typical indie project, so this one was based on, the numbers we got here were based on Cookie Cutter by Subculture Joint. You may have caught Stefano's talk earlier. And he's got about 12,000 sprites in his game. And that's typical, right? There's a lot of games out there that have much, much more. They use many more sprites. And so we want to add value to your workflows where it matters. And adapting the many thousands of sprites that you use in your games is at the heart of this effort. Increasing your efficiency in pre-production, during development, post-production, and beyond as well. This feeds into any workflows where you need to do rapid prototyping in your games, or where you're creating variants, or you need to rapidly produce post-launch content updates. Still on the subject of AI, I wanted to make sure that if you want to see more AI workflows that we're developing at Unity, you want to catch the talk tomorrow at 11 o'clock by my colleagues Martina and Manu. That's going to be awesome. They're going to go into more of the workflows that are being developed in AI directly in the editor. OK, Sprite Mask. We've been increasing the compatibility for Sprite Mask. What does that mean? So in the past, sprite masks could only use sprites, sprite assets, right, as the source of the mask. But in this latest update, Sprite Mask can use any of the 2D renderers as a source. So let's take a look at some of the different 2D renderers that you've come to know and love being used as masks. All right, let's start with the, well, let's look at the scene we have first. So we've got a gray stone wall, and at the back, we have a blue sky, right? I'm just turning it on and off here. And we've set up the wall to be visible outside the mask. This way, any pixels on any active sprite in the scene, any active sprite mask in the scene, I mean, will punch holes. So we start with a sprite renderer, for example. If we look at the sprite mask component here, you'll see that there's a new field called mask source. And it's set to supported renderers. So instead of having to specify a sprite asset like we did previously, we can use any of the renderers on this object as a mask. In this case, it's a sprite renderer with a cloud sprite on it. So far, so good. Here, we're using a 9 slice, right? So this has been set up correctly, and you can see it in the scene. And of course, it also supports sprites that are bound to a skeleton with a sprite skin, like Boris the snake here. Let's take a look at some of the other 2D renderers. How about tile map? So here we have a hexagonal tile map, and we've set it up the same way with a sprite mask component, and it's taking the tile map renderer as the mask source. Okay, so I'm going to use the paint tool in the tile palette, and I'm just going to paint some tiles, and as you can see, we're punching a hole through that tile map into the sky below. And finally, sprite shapes. In this example, we have an open sprite shape that we're just using the edge to create that mask. And last one, a sprite shape that just uses the fill. Now, what I like about this example is that the edges stay sharp as you zoom in, which means you can use this like a vector mask. All right, super. So I think this is fun, right? Because it really unlocks a bunch of creative possibilities. So this is a set of just quick game ideas that we were jamming on, visual ideas that we can do with the new masks. So here's a tile map renderer, for example, masking a particle system, because those work as well with the sprite system. Or maybe a mysterious character at the top right. Right? What we're doing there is we're masking with animated sprites, an animated sprite sequence. So this character is only visible in the reflection of these coins. Or possibly it's the sprite shape in the center, which is punching a hole in the foreground to reveal our hero, a secret agent, right? All right. Moving away from masks, let's take a look at sprite libraries and what's new with them. Now, sprite libraries are a great way to organize your sprites for level design and multi-part characters. This is especially useful when you want to swap between them, and we want to be careful not to confuse these with sprite atlases that are designed to group for rendering performance. But because sprite libraries and sprite atlases and addressables are all compatible, you can use them in combination to keep your larger projects organized. Now, one of the core use cases for sprite libraries and their companion component, the sprite resolver, is that you can use them to set up and sprite swap animation for multi-part characters. So one of the new things we've added is a sprite swap overlay right in your scene view. This means that this overlay reveals all the relevant labels that a selected sprite can swap to. Now, this also scales up. So if you have a multi-part character that's organized in a hierarchy like this, when any part of that multi-part character is selected, all the child objects with swappable sprites are displayed together in the overlay. If you use that in combination with the animation window, you have a system that makes sprite swap animation a lot more convenient right in the scene. Pixel art. This is a favorite subject for a lot of people. And pixel art remains timeless, of course. Right? Every year we see countless titles embracing this retro throwback aesthetic. Here we see Vampire Survivors by Ponkel. This is a great made with Unity example of pixel art and its unapologetic nostalgic appeal. It's a style choice we love, and it's not going anywhere anytime soon. Now, Sprite is the DCC tool of choice for pixel artists. It's the go-to DCC. And it's a wonderful tool for custom-made pixel art. The community is active and growing, and it's packed with useful features that pixel artists need. Layers, frame management, grids, indexed color palettes, pixel-perfect rotation, you name it. Now, the Unity A-Sprite importer is the best way to get pixel art into Unity. Similar to the 2D PSD importer, it's a great way to avoid exporting hundreds of individual PNGs or sprite sheets. You can work in A-Sprite, hit save, and instantly see the changes in Unity. There's powerful drag and drop support for A-Sprite files. And you can drag them into Unity, and the prefabs with all of the animation clips are automatically set up and ready to use. And there's comprehensive integration with all of the foundational 2D features with tile map support coming soon. So stay tuned for that. Now, the A-Sprite importer provides a much more streamlined workflow for pixel art, and there's much less manual setup compared to if you were importing these one by one. Also, the data from your A-Sprite project, all of those tags and layers and all the work that you've been putting into them, is respected and can be imported and used in Unity. This includes an option to import hidden layers, layer blend modes, layer and cell opacity, linked cells, individual frame timings, as well as layer groups. Okay, so we're going to see a demo of how easy it is to iterate with A-Sprite and the A-Sprite importer. And this demo is powered by the assets kindly provided by Soup Masters from their game Big Boy Boxing. So let's see an awesome teaser trailer for their game now. All right. Thank you, Soup Masters and Big Boy Boxing. Super cool. I think that looks like a lot of fun. Now I want to look at one of the assets from their game. Okay, so here we can actually see Bruno the banana. We saw him earlier in the video. And as you can see, all of the art for Bruno has been authored in A-Sprite. Here we are in A-Sprite. He's got some really cool animations, especially the attacks and the taunts. So we're going to see some of those, right? Lots of flexibility, really fun pixel art. And we want to see how this all gets imported into Unity. So I've added the A-Sprite file to the project, and I dragged it to the scene. And we can see that it's ready to use. So let's dig in a little bit onto what was actually made, right? Let's break it down. So we've got a model prefab. That's wonderful. And all of the frames have been imported and packed into a sprite sheet subasset. Now, the A-Sprite importer recognizes each tag in A-Sprite and creates an animation clip for it. And in the importer preview, you can see all the clips in a drop-down and preview them. There we go. Awesome. And an animator controller has also been created with a state for each of those tags. Now, the animation assets can also be extracted from the model prefab using this tool. And you may want to use this when you want to edit the animator controller state machine because you're trying to set up more complex state transitions. OK, I want to have a bit of fun now and use Unity as a look dev tool. So what I've done here is I've set up some post-processing effects and a shader to make the game look like it's running in an old TV with scan lines. And I want to make changes to the art in A-Sprite and then see the final effect in Unity. Okay, so we're going to be working on the left and then previewing on the right. I've set Unity to run in the background. This is important. And A-Sprite is set for background import in preferences. Now I'm going to hit play in Unity. And I'm just going to keep that running. Now, switching back to A-Sprite, I want to make Bruno look a bit more frenzied. So I'm going to start coloring his eyes frame by frame. I'm going to add in a little bit of yellow to begin with at first. So a few frames in, we're going to paint in some yellow. And then towards the end, we'll make it go a little bit red. OK, and we're doing this frame by frame in a DCC tool where we're comfortable. And then we just want to see the end result of this in an active instance of Unity running maybe on another monitor. I hit save, switch over to Unity, and without having to do anything, Unity just updates, and you can stay in the flow. That is cool. I love being able to stay in the creative flow like this, right? You're just working on the tool you like, and because we support background imports, you can stay there, save your previews, and Unity just updates without missing a beat. Now, Martin Callender, game director at Soup Masters, shared these motivating words with us. He said, "The A-Sprite importer has allowed us to animate on another level, truly. Without it, we just wouldn't be able to iterate at even a fraction of the speed we can now." So thank you to Martin and the team at Soup Masters. It's really been an honor. Let's not forget all the great Unity tools for pixel art games. There's Pixel Perfect Camera Component. This is not new, but it is something worth mentioning because it is a useful part of keeping your pixel art crisp and clear and rendering with pixel perfection. And here we can see a shader graph utilizing a dither node to create a dithered gradient on a 2D light texture. Now, these are all nodes available in shader graph with Unity 6, and you can use them to create these wonderful pixel art effects. And yet another 2D enhancer that we added, Pixelate, a quick way to pixelate your assets for games. We'll have a quick look at that. So I want to use the Pixelate enhancer here, and I'm in the big boy boxing arena in Unity, and I want to add a big red heart because clearly I love this game. And it's a pixel art game, so when I drag in the heart that I've got, it doesn't quite work. But because I can use the Pixelate enhancer, I can set the pixels to 64 by 64, and then the Pixelate tool will, of course, give better results if you choose art that matches the color palette and contrast ratios of your game. But there you go. I hit apply, and that looks much better now. Wonderful. OK, let's switch gears a little bit from pixel art productivity to performance. Now, there's something for those of you that want more control over performance. 2D now has SRP batcher compatibility. What does that mean? So tasks that you previously had loaded on your CPU can now be offloaded to GPU to free up your CPU for your gameplay code. Now, keep in mind that for sprites that are dense or that are skinned with bones, this is the preferred way to work, right? You'll get better performance. But for sprites that are rects or quads or that use very few vertices, you might want to disable SRP batcher, which makes sure that you fall back on dynamic batching because that's preferable for those kind of sprites. We've also introduced a 2D light batching debugger. Now, building a game is not a linear process, right? You have gameplay designers that are working out the gameplay, level designers and artists that are building up the scenes, making them pretty, making them work, and then teams who are going to go back and forth and review and refine. Now, we want to stay in that flow again, right, of making the game fun, keeping it looking good. So when it's time to actually optimize that, or at any time that you want to optimize that, you can pull up the 2D light batching debugger, and that will help detect human error or redundancies in the way that your sorting layers, your lights, and your shadows are working together. Now, running this is straightforward. In the 2D light batching debugger, you just select 2 consecutive sorting layers on the left. The debugger will get you a lot of intel about how the lights or shadow casters are breaking your batching, and then you can make better decisions about how lights and shadow casters should be affecting your sorting layers. And step 4, profit from improved performance, of course. So we ran this on some of our own samples that we had released in the past, and we were able, really pleasantly, to find human errors and things that we could have done better, and then we fixed those and resubmitted them to the asset store. So it was very useful for us, it's been useful for a lot of people, and we hope that you will try it out as well in your games. Okay, let's look at some 2D physics workflows. There's been a lot of interesting development in this space, and I want to highlight it. Let's dig into some of the powerful new 2D physics workflows. 2D physics now has substepping. What does this mean? You can keep your game's physics simulation accurate and consistent at low frame rates, right? So sometimes you're running a game, something happens. There's more stuff on screen, there's an expensive operation, the frame rate may dip, and that can cause a lot of trouble for the accuracy of the physics simulation. Now, in this one, for more control, you can configure exactly the FPS threshold where substepping kicks in. So here we can see it's set at 30. Now, you can also choose how many substeps you want it to do. We can show a little bit more in this animation. So if we look closely here, we can see a dip in the frame rate in the profiler on the right. Right? There's a spike there, so you know that something's going wrong. And so with the frame rate going down, we look inside the white box there, it's highlighted. We've actually turned up the substeps, the simulation count. So again, we do this because the time delta, the amount of time between the updates in the scene, the visual updates, has become too large. And so we want to run automatically more simulation steps to keep that simulation accurate and consistent. Okay, this one's just fun. 2D colliders now have layer overrides. So this means that physics layers can be included or excluded per object, overriding the layer collision matrix. So an example of this is you've got your game set up, you've got a lot of complicated global layer collision pairs, and you know what collides with what, right? But you have this one object, this one instance of an enemy, and for some reason, he's turned into a ghost, right? You knocked him down with your sword, and now he is able to walk through walls, but just that one object. And so you want to set the layer override on that so that he can't go through walls, right? So he won't collide with walls. Super cool. Simulation layers are something as well, something new. And these give you more control over what gets simulated at any given time. Now, these are useful when you want to control which parts of a simulation are turned on and off. So, good example is you've got an expensive simulation of things like ropes or chains, and you want to make sure that they are only turned on when you're close enough or when they come into view, right? So this is superior to using the sleeping of a physics body, since they are not considered even awake, right, when the scene loads. So nothing is processed unnecessarily. Okay, it's worth remembering that 2D collision meshes should, in most cases, be generated with Delaunay tessellation. We introduced this a couple of versions ago, and it is still the best choice for a lot of your art. As you can see, in the standard art, a lot of the polygons that are generated can be too numerous or too small or too thin, and in some cases, the physics system itself will discard these. So with Delaunay, you have a much better mesh, right? This is with the Delaunay on. And it works very well with the new composite collider merge and intersection operations. So let's take a look at those. So the composite collider 2D now supports these kinds of interactions where you can generate physics geometry by merging or intersecting or cutting different physics shapes. In the middle there, you can see the new support for circles and capsules. So now you can use circles and capsules along with the other colliders to create really complex shapes. And here we've even got them doing some of the composite operations, so there's some subtraction going on there. And then finally, this is a very common user request. A lot of folks wanted more control over objects that are on ramps and slopes, right? This is a common construct when you're building a platformer. And so the rigid body 2D slide functions allow you to do this. Better control over the movement of a rigid body 2D on ramps and slopes. Now, as always, I highly recommend you check out the samples. Our developer maintains a wonderful GitHub of all of the different physics features, and it's like a sandbox of everything working together. Because the 2D physics system is really rich, there's a lot going on. I would definitely recommend you check out that link there. And now let's look at some advanced customization from our users' requests. Now, we have some very ambitious users, and we've had many discussions with them over the years, and their requests have driven some of the customizations to the features that we want, that we've been meaning to add in 2D. So one of the first ones is a sprite shape geometry creator and also modifier. So we're going to focus on the creator here. So what this allows you to do, if we look at the two scenes above, is it allows you to override the sprite shape default creator. So in the past, if you've used the sprite shape, it generates a mesh to contain the visual inside it. And one of the things that you couldn't do, for example, was to have an inverted sprite shape, where the inside of the mesh was the level, right? So maybe you wanted to make a cave, or you wanted to punch a hole through the level. So what we've done here is we've created an inverted creator. And as you can see in the custom geometry field, we've overridden the standard creator. And that's how we get the one on the left. OK, scriptable packer for Sprite Atlas. So this is another common request. People are using a lot of different tools, and they are getting their data into Unity in interesting ways. And so we wanted to make sure that we could support that better. So scriptable packer allows end users to author custom algorithms for packing sprites instead of using the default packing. When might you need this? So let's say that you are packing sprites using an external tool, right? So for example, you might be using Sprite UV, or Texture Packer, or one of the many other solutions. But you want to import those sprites into Unity. You want to import all the metadata. And then you want to use the Sprite Atlas components, the Sprite Atlas asset inside Unity. So you can use the scriptable packer to help out with that. Another use case that comes up a lot is folks want to pack their sprites in specific predetermined locations. So a good example of this is you want to pack all of the particle frames that you're going to use in a fixed location. And then you want to use that in a flipbook, or maybe in a shader, or as part of an animation. And 2D Renderer now uses the render graph pipeline. So this automatically optimizes your render pass in the render graph to minimize the number of render passes and the memory and bandwidth that each render pass uses. It also avoids allocating extra resources so that the frame doesn't use those unnecessarily, and it merges multiple render passes into a single render pass. This also means that a lot of the renderers in Unity are now standardized on the render graph pipeline, which is a really good thing. All right. So I did promise you a sneak peek. Now, we're working on making it easier for you to mix 2D and 3D. I did see a show of hands earlier when I asked who's making 2D games, and in all of the when we've spoken to studios, a lot of them are mixing 2D and 3D, and it can be difficult. and you often want 3D objects to be part of your 2D game, maybe a guest 3D object, or you have a 3D object that's a character, and you want to make sure that you're able to render it along with all the other 2D pieces. Now we're going to show you some very early examples of this work that we call render as 2D. So typically, when you have two 3D objects, like these two cubes, and they share the same Z position, they're going to just intersect, like so. And this is because of Z-right and Z-test. So even when you use 2D sorting, we've changed it here on the right, they still continue to intersect. So now we've switched it to use render as 2D. Each 3D object is then fixed on just one layer. Okay, so here we see an example of a 3D character using 2D sorting. Oh, sorry. Let's just skip ahead. So we want to see an example of a 3D character that uses 3D character that uses 2D sorting here. And so this pixie here is a 3D character, and we can see that she's just sorting behind. And we can even turn on a sprite mask so that she's only visible inside the mask. So a 3D object rendering as 2D. This includes thinking about those 3D objects as being lit by 2D as well. So here we have another 3D character being lit, and the normals are being calculated, converted, so that the 2D lights can light them correctly as well. And there's shadows too. So some future work is happening in this area. We want to bring 2D and 3D a little closer together. And I hope you enjoyed that little sneak peek behind the scenes on what we're doing in the 2D team, cooking up something a little bit more interesting when it comes to bringing these two worlds a little bit closer together. All right, so that ends my time with you today. If you have any questions about the features or demos that you saw, or you want to speak to me a little bit more about 2D, I will be at the booth. I have many shifts there. Today and tomorrow, I'll be very happy if you come over, have a chat with us. Myself, Eduardo, Stefano will be there, and you can come to us with your 2D questions and concerns, and we'd be happy to chat some more. I want to remind you, please, to check out the best practice ebooks for artists and developers that the technical content team produces. As I said, they're packed with useful gems for all aspects of game development. And as always, keep making amazing 2D games with Unity. Thank you. I can hear the music, but I just wanted to make sure we've got 20 minutes. I'm happy to take any questions. If anyone has any questions they'd like to ask, I think there are microphones around the room. So if you have any questions, let's have a listen, and then let's see if I can help you out.
It's not. Is it okay?
Yeah, that's good. We can hear you.
Okay, great.
Hello.
Hi. Thank you for the presentation. It was really lovely.
Sure thing.
It's not a question, but a request.
Absolutely.
Can you
yes.
open the page about the GitHub document? Because I was trying to take a photo and I couldn't.
The GitHub document for physics?
Yeah.
Yeah, absolutely. Okay, let's get back there. Oh, there it was.
Yeah. Thank you so much.
Sure thing. I saw a few more hands over here.
Yeah.
And then there's a few at the back as well.
If you want to, thank you.
Hi.
Hello.
Thank you for the presentation. Amazing stuff. And
you.
Specifically about this last thing, the sneak peek for the render as 2D, which is awesome.
Wonderful.
Yeah. I was wondering if there is any chance that that same feature or similar could get to the Canvas, Yugi, or even UI Toolkit world, because that's a recurrent thing in all the projects I've worked in.
Yes.
Like mixing 2D
Yes.
and 3D, but
Yes.
in UI with
Yes.
the canvas specifics.
Yeah, that's a really good question. And it's something that I would say matters a lot to a lot of game developers. I'll take it on as a feature request. It's absolutely not the first time that we've heard it. We are considering it as part of the work. So thank you for that. It is something that we are thinking about very, very seriously. Thank you.
While we're on the topic of UI and canvases, when you mentioned that 2D renderers are now in the render graph pipeline, does it also include image component and UI things?
That's a good question, and it's a question for the UI toolkit team. I'm afraid I would love to be able to have an answer for you on that, but,
All right. I have a backup question.
Yeah. Second time lucky. Let's do it.
Does the sprite mask support alpha soft masking?
Okay. So if you look at the new, the new sprite mask, so it supports a lot of different renderers, but it still uses essentially a 1-bit alpha with a tolerance, right? So what you want to do if you need soft alphas is you need to get into shader graph and make a custom shader with a field for something to use as a soft mask, because they are very different in terms of performance. Yeah.
Sweet, thank you.
Yeah, absolutely.
Thank you. I see that everything that is talking about 2D is 2D renderers, and you mentioned that the UI toolkit is a different team. But what about the normal UI that is not the UI toolkit, right? Because that's also 2D, right? I feel like it's been left behind. And one of the questions that I have, maybe it's even not for your team, because of course, for some reason it's too different to this.
Yes.
About particles in the normal UI, like there has never been really good support for just adding particles. There's always been like little hacks here and there.
True.
Like I will really love to go into the menu and say, Unity UI particle, right?
Yes.
Is there anything in the roadmap or anything for this?
So again, it's my least favorite thing to say to you is not my team. I hate saying that. But I will take on the feedback and bring that to the UI toolkit team, because that is the future of UI in Unity, right? I think the initiative is to bring as many things together, to simplify as many things together. But again, I won't speak on their behalf, but I will take your feedback. I completely understand that we want particles and basically all renderers to work together in harmony, right?
And just one more question about the AI generated, this Muse. Is this like going to be available already on Unity 6? And is this subscription based? Like, is this that you have to subscribe and then you get access to Muse, or Muse is going to be access for free on Unity 6?
Again, very good question. So I won't comment on the business side of it yet. But when it comes to the generators, to the enhancers that you saw today, that's in pre-release. So if you go to the discussions page for Muse, we will be sharing a link there, or you can go to the Unity Muse page on the Unity website, and you can easily get hold of all of the packages that are available today. We have trials available for those now, and then later on, we will get more crisp about how you can use those in your projects and what the business model is behind that. I hope that helps. Yeah. Did I see anyone else? One more. Okay. Wonderful.
Okay. Thank you for the presentation.
Absolutely.
My question is about Sprite.
Yes.
The plugin is generating animation for sprite renders, but not from the canvas, right? For the UI canvas.
Okay. Again, so Sprite, what we do when it comes in is we create a model prefab, and then we allow you to convert any of the tags from Sprite into a series of frames in Unity or layers in Unity. And then all of those are rendered, you're right, as sprite renderers. Nothing for the UI canvas right now.
Okay, so yeah, but I have the assets, so I can create my own animation. Yeah, but it's not
Exactly.
automatically. That's the thing.
There you go. Yeah, we don't automate for the UI canvas.
Okay,
Yeah.
thank you.
Absolutely. Super good. There's one more right behind.
Oh, you? Yeah. Okay. If you don't mind.
Hello.
Hello, how are you?
Fine, and you?
Good, thank you.
When you use the enhancer on a sprite, does the new sprite, is it a new sprite for a new instance, or does it store the metadata of the changes?
Okay, good question again. So when you use an enhancer on a sprite, we store the data inside, so the way you see it there, it stores the data in the sprite as a link to where the actual data is being stored in the cloud. So your sprite has all the history of everything. So if I kept on enhancing, you would be able to see all of the results. You may have noticed that there was a results window and everything was going in there. So you can actually see the history of all of the work that you have done to enhance that sprite. So if you're recoloring and then maybe after that you upscale and then you copy that and then you recolor it again, all of that history stays there with the sprite so that you can choose between the different variants that you have created as part of your process.
And when you choose one and like build it, is it a single sprite?
You only get the one that has a reference in the scene. Yeah, it doesn't bloat the size of your project. Good question.
Thank you.
Yes. Wonderful. Any more? I see one hand at the back on the right.
Okay.
And then several over here. Sorry, the house lights make it impossible to see everyone.
Over here, right? Yeah. Thank you. Hi, thank you so
Hello.
much for the presentation.
You're most welcome.
I actually wanted to follow up on the question about recolor, because I did
yes.
see you dragged the scene reference to create the actual color palette that
Yes.
would kind of recolor the asset. So I was wondering, is that customizable? Can I work with my own palette? Do I have to drag an image? Like, how does that work? And how much of control do I have as an artist?
Absolutely. Okay, so this is the first instance of recolor. And so the feature at the moment allows you to drag a reference image. So if you want control over what palette gets created, you need to change a reference image. So one way that, so we've had a few folks play with the tool, and one way you can do that is by making a reference image with the color palette that you want, and then dragging that in. In the future, we may add more customization. We want more feedback from folks actually using the tool. When we hear things like that, I'm always a big advocate for more creative control. You can see it in the other 2D tools. We've added a lot more creative control, but we want to do it in a controlled way via feedback from the users. So thank you very much for letting us know.
That makes sense. Thank you.
Sure thing. The gentleman at the back, and then the gentleman in the front.
Yeah, over there. Yes.
Hello? There we go.
Hi, how are you?
Thanks for the presentation. About the very last thing you showed, like the preview.
Yes.
Are there any plans for when this will be released to the public, or is that too specific to ask? Yeah.
We love giving specific dates. No, so the whole point was to again, we're trying to be a little bit more transparent with what we're working on, and so no specific date.
Yeah.
But it is something that is already in flight, something that's already being worked on, and we'll probably release it in phases, and each phase will be useful. Yeah. So that's the way we want to think about it. So first of all, render as 2D makes a lot of sense, but more unification, more streamlining, probably in the future. But sorry, no specific date.
No, that's fine.
Yeah,
and then
absolutely.
One maybe follow-up question, also about kind of the same thing. You showed sprite masks for 3D objects.
Yes.
Is that only if the 3D object is, or currently maybe you plan to change it, or have still like fake plans? But if that's only usable for the 3D objects that are listed as 2D rendered,
That's correct.
Or
Yes.
is it not like usable for 3D objects that are just not rendered on the Z plane?
Correct. So for us to be able to use the sprite mask with a 3D object, it needs to be rendered as 2D.
Okay, yeah, I see. I see.
Yeah, because otherwise it doesn't fall. But again, that's a good question because it speaks to the fact that we should probably be doing even further unification steps in the future. But good question. Thank you.
Thank you.
And there was one more gentleman right in the front. Second row. If we could get a mic, if you speak really loudly, I'll probably hear you too.
Hi.
Hello.
My question is that when you cast the object from 3D to 2D, the last part, what happens with the shadows that generates the object when the lights, I mean, 3D lights will still have affect the shadows that produce the object, or only will the 2D lights have shadows with the object?
Okay, so the simple part of that, the simple answer is 3D lights will no longer work on that object in that demonstration, right? That's where we're at so far. 2D lights will work with the 3D object and they will cast shadows. That work is still in progress and will probably not be part of the first phase of the release because there are some complicated things we need to do around generation of shadow shapes for 3D objects, and they are not stable as the object rotates. So they need to be modified at runtime, depending on the transform of the 3D object. Okay. But yeah, that's so 3D lights don't work.
Well, and these shadows will be customizable. I mean, you can change the type of color if it only affects to some parts of the object.
So they are 2D shadows, and they would have all the capabilities of 2D shadows today.
Okay.
And if we add any enhancements to the rest of the 2D shadows in the future, the ones that work with 3D objects that render as 2D will get the same improvements. That's the normal way we would do it.
Okay, thanks.
Yeah, absolutely. I really like these surgical questions on what exactly did you mean when you said render as 2D. It really helps because it helps me understand what people's expectations are and really what you need when you're talking about mixing 2D and 3D.
Hi.
Hello.
With the 2D mask, with the 3D objects, you showed like you apply a 2D mask to a 3D object, but is there a way to do it like the inverse, like a 3D object that applies a mask to a 2D object?
Not in the work that we're doing now, but is that a feature request? And if so, can I understand what you would need it for?
Like generating complex geometry that you can act as a mask for other objects in the scene, in the 2D scene.
Okay, so you have a 3D object that you want as a mask.
Yeah.
So that means that the 3D object silhouette would be used as a mask in 2D. Okay, I can take it on board, but maybe we can chat afterwards as well. I want to understand why you're doing that. You've given me a little bit more detail. I want to know, paint me a rich picture so that I understand how you would use it in your game. But thank you.
Thank you.
It's a good question. Okay. I think we're done. Thank you very much, folks.